Okay. Sorry, I had to set up a video because my first video did not work. So we are going to be solving exponential equations. Okay. All right. So to do that, we're going to we'll start with some like easier ones that don't require a calculator, and then we'll get into ones that kind of do require a calculator. All right. And so our directions here are just going to be, for all these, we're just going to be solving for x. Okay, trying to get that x by itself. All right. So let's start out with our problem here. We'll say we have 8 to the x equals 2 to the 6. And so option 1, anytime we have a calculator available to us, all right, and the directions don't specify whether you can or cannot use a calculator, right? You could just use your calculator to solve an equation. Anytime you have an equation and you want to solve it and you're like not sure what to do, you can use your calculator. The easiest way to do it is type into your y1, okay? Type the left-hand side into your y1, type the right-hand side into y2, graph it. Okay, actually, I better go back here. Graph it here in your normal viewing window, and you can see, well, it doesn't really fit, right, because I'm graphing 8 to the x, there's that curve, but 2 to the 6 is a pretty big number, it's 64, and so we need to adjust our window here, so I'm going to go to window, and that means I need my y max to be more than 64, so I'll say like 70. Okay, and now when I graph that, there's my curve 8 to the x, and there's 2 to the 6th, right, just a horizontal line that goes through 64. And so the solution to this equation will be located, second trace, at the point of intersection. So my first curve here is the 8 to the x, the next one is 2 to the 6th. And I'll just move my little cursor there close to the point of intersection. And so with my calculator's analysis here, the solution to this equation has to be 2. Right, it must be 2. So we know by the calculator that x equals 2. Okay. Alternatively, though, right, we could have like solved this without a calculator. This one's not that hard to do without a calculator here. I mean, if we just, take 2 to the 6th, okay, and rewrite it as 64, well, now it's pretty straightforward, right? I mean, what power of 8 gives us 64? Well, that would be 2. So we could just say, again, oh, okay, well, x is 2 from that, seeing it that way. And then the third way to do it, that also is helpful, okay, is to start back at this 8 to the x equals 2 to the 6. And we can get a common base, okay? So the kind of our goal here maybe is to rewrite the equation, all right, in terms of a common base. This is one way we can do some of these without a calculator, but still kind of do some algebra, So what would our common base here be? 2, right? Yeah. 8, okay, is just 2 to the 3rd. So instead of saying 8 to the x, we'll say 2 to the 3rd to the x equals 2 to the 6th. Okay? But then a power raised to a power, so 3, 2 to the 3rd to the x, what can we do to simplify those exponents? We what? Multiply. So 2 to the 3x equals 2 to the 6th. Alright. And saying then, okay, well, these two things are equal. The left-hand quantity and the right-hand quantity are the same. The bases are already equal. So then what do we know has to be true about their exponents? They must be equal as well. So we can just say 3x equals 6, and so then x equals 2. Okay. So lots of different options here to go with, lots of strategies. And of course, you just pick one that works, right? Go with one that works. But this common base idea is helpful. Okay, it can be helpful. All right, so let's try another one here. Okay, again, we're going to solve for x. We'll do this one here together. So let's say we've got 7 to the third of x over 49 equals 1. So of course we could use our calculators. We could graph the left-hand side and y1, graph the right-hand side and y2, find the point of intersection, or the x-coordinate of the point of intersection. That would give us the answer. But can this be rewritten in terms of a common base? And if so, what would that common base be? 7, okay. So, well, let's see here. So we already have this one as 7. It's 7 to the 3 to the x. So let's go ahead and multiply those exponents, make it 7 to the 3x. Okay. What is 49 as a power of 7? 7 squared, right? 7 to the 2. Okay, equals, and then what's 1 as a power of 7? 7 to the 0. That's right. Yeah, 1's an easy one because it can be any base. 7 to the 0. It looks like 7 degrees the way I wrote it there, but it's 7 to the 0. So it's all in terms of 7s. We have a little bit more work to do here on the left-hand side. There you go. That's okay. Okay. What can we do here still? When we divide common bases, what can we do with our exponents? Subtract them, right? So this becomes 7 to the 3x minus 2, all in the exponents. 7 to the 3x minus 2. And that's equal to 7 to the 0. Okay. And so if we've got 7 to the 3x minus 2 equals 7 to the 0, same bases, both the values are equal, so what do we know, what must be true about their exponents then? They must be equal as well, that's right. So 3x minus 2 must also equal 0, and so we can solve them there. Okay, more papers, thank you. Okay. And we solve, and x is 2/3. Okay, x equals 2/3. Okay. Questions on any of that? No? Okay. So let me give you guys 2 to try here. Let me give you 2 to try. Again, the answer is to solve for x. And you may use any strategy you wish. You may use any of the strategies you wish that I've given you thus far. Okay, so try that one. Okay, that's the x right there, that's x. And then try this one. Okay. And I will be right back because these papers are not for a student that belongs to me, but I think I know who they do belong to. So I'll be right back. So go ahead, give those 2 a try. Again, you may use any strategy that you wish. All right, volunteers. For number 1, what do we say? Some people are still working, I see. That's okay. That's good. So number 1, can we rewrite it in terms of a common base? Yes, what's our common base? 3, that's right. So this is 3 to the 3rd to the x, and this, well, let's see here. 81 is 3 to the 4th, but it's also then to the 1/3. Okay, so again, power to a power, we multiply the powers to simplify, so it's 3 to the 3x and 3 to the 4/3. Same base, equal quantities, the exponents must be equal to then. 3x equals 4/3. So we finish by dividing both sides by 3. X is 4/9. Okay, or 0.4. How about number 2? Can we get a common base here? No, we can't. Was anyone able to solve it? Yeah, what'd you get? 3.8. 0.7. Keep on going forever and ever. Yes, that's right. How'd you do it?
I plugged in my calculator.
Calculator, yeah. We'll graph the left-hand side, graph the right-hand side, found the point intersection. Okay, yep, that works. There's an alternative, though. So rather than using your calculator, alternative to that, we can kind of, divide both sides by 3, for example, right? This is like solving an equation. We want to get the x by itself, so let's get rid of that 3 because it's 3 times 2 to the x. So divide both sides by 3. We're left with 2 to the x equals, let's see, 42 divided by 3 is 14. And so you now see we really run into the problem, right? Because 2, well, that's only can be written as a power of 2, right? And 14, that's not a power of 2, not an easy power of 2. We can estimate this answer, right? We know that the x value is going to have to be between 3 and 4. It has to be between 3 and 4 because 2 to the 3rd is 8, 2 to the 4 is 16. So between 3 and 4, we're just not sure exactly, what that number might be. So how can we solve for x here when the x is up in the exponent like that, right? So yes. Yeah, so we can use logarithms. We can do a log to both sides of the equation, and specifically here, log base 2 might be a good idea. Why did you pick log base 2 here, James?
Because we're evaluating what the power of 2 equals 14.
Yeah, so we can rewrite this thing. So we'll do log base 2 of 2 to the x, and we'll do log base 2 of 14 like that. Okay? Now, log base 2 of 2 to the x, what does that simplify to be? Just x. Yeah, just x. What power of 2 gives us 2 to the x? Well, it's just x. Or you can imagine pulling the x out front and doing log base 2 of 2, which is just 1. It'd be 1 times x, so x as well. And so we know that x equals exactly log base 2 of 14. But of course, that's not precise. That's precise. But we want to, try and get in terms that we might, be more familiar. So we'll do the decimal, which we don't have a log base 2 button or calculator, but we do know how to change base, right? So log base 2 of 14, and it's up to you what you want to do. You can do log of 14 divided by log of 2. Please make sure you close your parenthesis, by the way. Okay, if you don't close that parenthesis on the 14, you are done. Game over. Okay. And then, you can use natural log. Either way, you get the 3.807, so on and so forth. Okay. Nice thing about this, right, is you can check your answer too to make sure it's right. So we could do 3 parentheses 2 to the answer that we just did. And sure enough, we get 42. The ANS command, right, is second negative sign, and that allows you to, in your calculator, that lets you use your previous answer in more mathematics. You can have it so you get 2 to the answer. If you don't like doing that, if you want to just retype everything, you can. You can do 2 to the 3.807354922, and it actually just makes it 42 there. So yeah. Good question. My recommendation: 3 decimal places. 3 decimal places. It's good practice for calculus. Okay, if you plan on going on to calculus. So 3.807, I would say. Okay, we don't do sig figs here.
If we didn't get a calculator on that, what the answer would be?
You'd stop at log base 2 of 14 and just start with.
Is that going to happen like on the test?
Sure, good.
So we're not going to be able to use our calculator on some part of that?
potentially, yes. But if you are allowed to use your calculator, that'll let you not only round your answer, but really that'll allow you to like use that whole equation thing and solve for the left-hand side and solve for the right-hand, graph the left and right-hand side and set them equal. So that is an option if you have your calculator available. So, yeah, you definitely still want to know how to do this without a calculator, for sure. All right, 2 more problems I want to show you here. 2 more. We'll do another one like this one that we did. So let's let's solve for t. Okay, solve for t. And so we'll do 6 times 2 to the t plus 5 plus 4 equals 11. 6 times 2 to the t plus 5 plus 4 equals 11. Okay, so at this point we're kind of throwing the whole get a common base idea out the window because we have like 11 and we got like 6 and none of those things are really bases with 2 and stuff, so we're going to forget about it for right now. And instead we're going to solve this like we kind of normally would, right? Solve the equation. So we're going to subtract the 4 over and get 7. And divide both sides by 6. Again, kind of like usual. Typical equation solving. We're kind of isolating the exponential here. And so now that we're at this point, right, kind of at this point, we would want to, if we could, we really want to be able to rewrite this 7/6 as the power of 2. But again, that's not an easy power of 2 to rewrite. So we really can't use that strategy. But we can use a logarithm to get that t plus 5 out of the exponent. So what log could we use here? So we could use log base 2. Yeah, log base 2, exactly right. You could use log base 2. But actually, any logarithm works. Let me show you. So we could do log base 2. Actually, I'll do it with log base 2 just so you can see it that way. So if I do log base 2 of 2 to the t plus 5 equals log base 2 of 7/6. Excuse me. Okay. Again, what power of 2 gives me 2 to the t plus 5? Well, it's t plus 5, right? This basically just becomes t plus 5. Okay. Equals, and then log base 2 of 7/6, no idea what that is, but we'll just leave it like that for right now. And then to finish solving for solve for t, I just got to subtract 5 from both sides. So it's log base 2 of 7/6 minus 5. Okay. Or approximately, log of 7/6 divided by log of 2 minus 5. So like negative 4.778, I would say, since that 6 would round. Okay, negative 4.778. Option 1. Option 2. We don't need to use log base 2. For example, let's say I use natural log here. Okay, so let's say I use natural log here. Well, I can still use these properties. The t plus 5 would come in front. I could pull that t plus 5 out front. But now the natural log of 2 doesn't cancel out, right? Because natural log of 2, that doesn't simplify to like 1 or anything like that. Here, log base 2 of 2 would become 1, so it's just t plus 5. But here it's natural log of 2. Okay. So to solve from this point, I would need to divide natural log of 2 over. Like that. Which, that might look worse than log base 2 of 7/6, but when we go to type this in our calculator, we would type the exact same thing, because to evaluate log base 2 of 7/6, we have to do a change of base anyway, so it's going to be end up being the same thing, really. And so we end up with the same answer. Natural log of 7/6 divided by natural log of 2, and then minus 5 So it doesn't really matter what logarithm you use. If you want, you can use natural log every single time. Okay? Or if you want, you can always try and match your logarithm to the base of the exponent that you have. So for example, 2, okay, log base 2. The only difference is that here, the base and the logarithm cancel out, you're left with just t plus 5. Here, since the natural log has a different base than 2, right, they're different, then you just leave it as natural log 2, and the t plus 5 comes out front. You divide it out by 2. That's all. It's the only difference there. Okay, questions on that one? It's a little funky, but up to you. Okay, and then lastly, I got one more I want to show you here, and this is again solving for x. Making use of all my space today, just about all my space. Okay. E to the 2x minus 3 to the x plus 2 equals 0. So we got some exponentials in here, but the problem is now we have like 2 different exponentials, and we can't get them together as one, right? All these other ones, we had just a single exponential. It was 2 to the x. Here it was 3 to the 3x. Here it was 7 to the 3x minus 2 equals 7 to the 0. Right here it was 2 to the t plus 5 equals 7 to 6, so you're able to solve it. But here we've got 2 different exponentials, and they're not like. This is e to the 2x minus 3 e to the x. They don't combine together. But e to the 2x is the same thing as e to the x squared minus 3 times that e to the x again plus 2 equals 0. What does this really look like? Quadratic, which we could maybe then factor. Exactly right. And so let's look here. We need 2 numbers that multiply to make 2, positive 2, but add to make negative 3. Well, negative 2 and negative 1. And so there's the factors. E to the x times e to the x will give you e to the x squared, or sorry, e to the 2x, I mean. Same thing, e to the x squared, e to the 2x. And the minus 3 e to the x there from the minus 2 and minus 1, and then the plus 2. So it works. And you can then break apart. E to the x minus 2 equals 0, e to the x minus 1 equals 0. So e to the x equals 2, e to the x equals 1. And then at this point, how should we proceed? What should we do to both sides? Natural log. And so the natural log of e to the x equals natural log of 2. Natural log of e to the x equals natural log of 1. Natural log of e to the x is just just x. And then the natural log of 2, well, that's going to be some decimal. And then the natural log of e to the x is just x. And the natural log of 1 is 0, 0, 0. Because then e to what power gives us 1? 0. So there they are. Okay. There are 2 roots. Natural log of 2 is about 0.693. Okay. Easy peasy. Maybe not, but there it is. So, let me give you guys your assignment.